So what I want to talk about today for chapter 30 in particular, I think that's what we're on. This is all about atomic physics, and there's some simple equations they give you. I also want to talk about quantum numbers. Did you learn about quantum numbers in any of your classes? Nobody has ever learned about quantum numbers? No? Okay, and you took chemistry. How many have taken chemistry? Okay. Your chemistry teachers are bad. They should be teaching you about quantum numbers. So we know some stuff about electrons, right? If I draw an atom, right, we have this thing at the middle. What's the thing at the middle? Nucleus. And we have things orbiting around. What are those things that orbit around? Electrons. And this is called the Bohr model of the atom. What's the simplest atom you can have? Hydrogen. Okay, so we know a crap ton of stuff about hydrogen. We know that the energy of any electron level in hydrogen is actually equal to negative 13.6 electron volts over n squared. It's kind of useful. But we also know that we can describe all of these electron states, n equals 1, n equals 2. We can describe exactly where the electron is in those states with 4 different numbers. And these numbers that we can use to describe where an electron is are called the quantum numbers. And there's 4 of them. The first quantum number we call n. N can be 1 for the first orbital. It can be 2 for the second orbital. It can be 3 for the third orbital. What's the fourth orbital called? First one is 1. Second one is 2. 4. What's the infinite orbital called? Infinity. So n can go from 1 all the way up to infinity. And this is called the principal quantum number. And the total number of n states you can have inside of an atom, the total combinations of quantum numbers you can have, is actually n squared. 2n squared. Total combos of quantum numbers. And we'll see what that means in an example. And last thing, because this is a physics class, chemistry, that's where they'd stop teaching you, because that's all they understand. They don't actually know how anything really works. The n quantum number tells you how big your orbital is. It's a size. So n is the first quantum number. Second quantum number is L. L starts at 0, and it can go all the way up to n minus 1. This is called the orbital quantum number or angular momentum quantum number. A lot of times we describe the L level with actually a letter. So this gets really funky. But L equals 0, let's say 1, 2, 3, 4, 5. That's where we'll stop. If L is equal to 0, we call that an S state. L is equal to 1, we call that P. L is equal to 2, we call D. L is equal to 3, we call F. L is equal to 4, we call G. L is equal to 5, we call H. Just to make life more miserable and complicated. Again, we'll do an example where we show you exactly what this all means. Okay. And then that's where the chemists stop, because chemists, do they understand anything that they do? No, they just memorize stuff. Physicists, we understand what it actually is. The L quantum number tells you the shape. your orbit. And electrons, they can orbit in different shapes. They can orbit in circles. They can orbit in peanuts. They can orbit in 3-leaf clovers, 4-leaf clovers, all sorts of funky shapes. That's what L tells you. Third quantum number, M sub L, also known as the magnetic quantum number. M sub L goes from negative L through 0 all the way up to positive L in integer steps, in whole number steps. So if L is equal to 2, M sub L could be -2, -1, 0, 1, or 2. The number of M sub L's that you can have, we call them sublevels. And the number of sublevels you have is 2L plus 1. Physically, this tells you the orientation of your atom. So I could have a peanut that looks like this, up and down, but my peanut could also be going side to side. This M sub L tells you the orientation of the peanut, the orbit. All right. And then last of all, the fourth quantum number is M sub S. M sub S is the easiest one. It's positive 1/2 and negative 1/2. Every state that you have inside of an orbit, inside of an atom, every combination of the above 3 quantum numbers can also have an M sub S that's equal to positive 1/2 or an M sub S that's equal to negative 1/2. And this tells you the spin. Depending on the book you read, the spin could be up or down, or some people like to do counterclockwise and clockwise. Okay, that's throwing a whole lot of stuff at you, and you've never seen this in your chemistry classes because your chemistry teachers are awful human beings and don't deserve to breathe the same air that we breathe. Let's do an example of this. So let me tell you that I have an electron that's in the n equal to 3 state. And I want you to write all the combinations of quantum numbers that you can possibly have. I want every single quantum number state that you can have. So that means that you have to write all the n, l's, m sub l's, and m sub s's that you could have for this. And to know how many of these you have to write out, the total number of states, the number of states is equal to 2n squared. So how many different states are we going to write out? What is 2n squared for this? 18. So I have 2 times 3 squared is 2 times 9 is 18. Got to write down 18 different states. It's a pain in the butt. Let me show you how I do it. Okay, n is equal to 3. That means L has a few numbers. What different L's can I have? Remember what's the rule for L? Where does it go between? 0 all the way up to n minus 1. So what's the highest L that I can have for this? 2. And I start at 0. Any numbers in between 0 and 2? 1. So I could have L equal to 0, 1, or 2. And because we want to confuse students, do we use numbers for L?
Of course not.
course not. We need to make it complicated, so we need to use letters. What is L equal to 0? What letter is L equal 0? Is S. What letter is L equal to 1? P. What letter is L equal to 2? D. Okay. Now I also need my M sub L's. Okay, what M sub L's can I have? What's the rule for M sub L? Negative L all the way up to positive L. Okay. So how do I do this? Okay.
Is it all the numbers between negative 2 and 2?
So if L, let's say I have N equals, let's look at this first column. Let's say N is equal to 3, L is equal to 0. What M sub L's can I have here?
0.
I can have 0. So that's just 1. That's 0. Huh? Okay, let's look at the next one that I can have. If L is equal to 0, if L is P, or L is equal to 1, L is P, what M sub L's can I have? I can have negative 1, and it includes 0, so I can go negative 1, I can go 0, I can go 1. And what about L equal to 2? What M sub L's can I have? Negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, 2. And what about M sub S? What can M sub S be? It can be positive or negative 1/2 for all of these. All right, so what you got to do now is you have to write out all of these states. And how many of them are there? 18. Let me show you a shortcut. It's not actually 18. It's actually 9. Okay, so let's write down all the states. So when writing down all the states, you take your N, you take your L, you take your M sub L, and then your M sub S is actually 2 states, positive or negative 1. So the first state I would have is N equals 3. L equals 0. If L equals 0, M sub L is 0. And M sub S can be positive or negative 1/2. Does that make sense? So I have 3. L is equal to 0. But what is 0? Is L equal to 0 actually 0? What is it? It's S. So I have 3S. And then what's M sub L in that case? 0. And what's M sub S? Positive or negative 1/2. So this is one line, but this one line represents 2 different states. It's 3S0 positive 1/2 and 3S0 negative 1/2. Okay. Now let's do the next one. So another state. Let's say N is equal to 3. I took care of the zeros, so I don't need to worry about those. 3, and then L is equal to 1. And what could I have for M sub L then? I could have a negative 1, I could have a 0, or I could have a 1. So that's 3 different states. I can have N is 3. L is equal to 1. If L is equal to 1, what letter do I write? I write a P. And then what M sub L's can I have? can have a -1, I can have a 0, I can have a 1. So it could be -1, it could be 0, it could be 1. Those all come along with 3p. And then what's m sub s for every single one of those? Positive -1/2, positive -1/2, positive -1/2. Okay, how many states have I written out now?
4 or
8. That's 8 of them. How many more do I need? 10 more. Okay. What's the next state? What's n? 3. What's L? D. What's m sub L? -2. Or what else can m sub L be? -1, 0, 1, 2, 3D, 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 all filled straight down. Positive -1/2, positive -1/2, positive -1/2. Okay? And you can check yourself. You can make sure that you have the right number of levels, depending on what your L's are. You need 2L plus 1 sublevels for any kind of L that you do, so you can calculate those out. So let's try this one. What is 2L plus 1? 1. How many sublevels are there? That's just the 1. Okay. So you can check yourself on all these things. Any questions on quantum numbers? Quantum numbers are like puzzles. If you think of them like puzzles, makes them a little bit easier, a little bit less tedious. It's like, yeah, it's a very nerdy, it's a nerdier Sudoku. It's all just following a couple of rules. I'm horrible at Sudoku. I can barely say the word. I pronounce it Sodexo, and I think that's who provides food here.
Yes, no, it really is.
Okay. Any questions on quantum numbers? No? So I gave you an extra quantum number worksheet to help out with solving for quantum numbers. So you should do that as well as the homework problems. Homework problems are all based on equations that are in the chapters, and you've already hopefully watched that to learn about those. Any questions? Okay, pop into those.